So, I'm going to talk a little bit about some of the more practical aspects of some of the things that Mark was talking about. This will be kind of a selected list of topics, and so I think the plan is to go through. I'll start by kind of going through and showing you some of these web pages, some of which he mentioned um, before in a little bit more detail, and some other ones. And so I'll kind of walk you through how to find information, where it's located, give you examples of what to do, and then when we reached maximum information overload, then we'll go and do a couple exercises about trying to submit some jobs and run some of the code that you guys developed previously over actual data on the JLab batch farm. So yeah, when I'm showing off websites, feel free to follow along by yourself or poke around while I'm talking. That should be fun. There's a number of topics that I won't cover. I won't cover building the software from scratch. So for HDPM or build scripts, you'll have to either go look on the website or ask one of us. Mark will walk you through it, I'm sure. Also, as part of, as a GlueX member, we also have access to resources on the Open Science Grid. So that can be used for simulations or doing analysis of data offsite. There's no transparent way to get data, from JLab over there, at least at the moment. So if you have questions about that, Richard Jones is the main contact for the GlueX collaboration on that effort, but I can answer some questions about that as well. And I won't cover any more about Event Store. I talked a little bit about that at the collaboration meeting, and it's things will change a little bit in a couple of months. What I say today should be pretty much relevant all the time, but I think that's a topic that's getting cut for time. So okay, let's look at things. Okay, so the main topics that I'm going to cover here, we'll look about accessing this REST data. This is our reconstructed data, various metadata. So we have, all these nice web pages. This is the batch farm system, the interface to it, and so why don't we get started? So RCDB, this is the run condition database. This is sort of the canonical source for the information about all of our different runs. A lot of other information about data taking and the different conditions. So this was put together by Dmitry Romanov, and it's been, a really nice tool. We found out. Okay. So let me go through, just kind of give you a brief glimpse at the website. So this is the main page. If you go to RCDB like that, and so here it kind of gives you some summary information on here. You can see that, hey, not much data taken around here. These are some periods of good data taking. And, it gives you a list of runs. But what's really nice is this search functionality. So let's say I wanted to find, search for a bunch of set of runs. So there are two different types of searches that you can do. One is you can, do simple searches on various run conditions. So you can find the list of that here. There's a bunch of them, and we're adding to them all the time. You can do searches, about which radiator's been using. Is this a para versus perp run? You can put restrictions on the beam energy, but a good place to start. But there are also these search aliases. And so an alias is defined by the @ symbol. If you if you type @ it'll give you this list. Sorry, this is auto-completion's popping up. Okay, yeah. So it gives you this list of different aliases, which are kind of predefined in the system right now. And so let's say, probably what you want to do is you want to look for, at least in our case, the actual good runs that have real physics data in them. So the basic search for that is at is production at status approved. So we do that search. We wait a little bit, and this list of runs pops up. So, here you get some summary information. You can do various things. Unfortunately, this doesn't quite work yet. So this is what Dimitri's working on right now. But you can do a bunch of things. So if you click onto here, there are links to look at the run browser or the elog entry. If we click on one of these runs and look at it, you get all the information that you would possibly want. Run, end time, all these other things. So this is a really convenient way to look at data. Look at information on the web. Sometimes you might want to get, make some summary information though. So the RCDB also has, APIs for various languages. If you go on the wiki page, it'll give you a lot more detail, things like that. Probably the main interface for kind of, looking at this, information and, summarizing it is Python. So. So let me just point out a couple things. So the two main ways that you can work with this stuff on the command line is with the Python API. Here's an example of what it looks like. Pretty straightforward, connecting to a database. You get some value, or you can get some information over a set of runs. The information the wiki pages has some pretty good explanations of that. There's also a command line command, this rcnd, and so this lets you do similar searches, lets you update information, things like that as well. In terms of the queries, you can use just a little bit more information on that. This is it lets you do various Python-y things. So you can do simple comparisons, strings. You can look to see if it's your value is in some sort of array. And I mentioned these aliases before. So this is in the process of being developed. There's a lot more things. I think that the next version has the ability to set aliases for the website, in your own directory. So you can define your own aliases, and then when you go to the website, they'll automatically pop up. I don't really know how that works, so I haven't had a chance to play around with any of that yet. But it's pretty convenient. Also on the GlueX webpage, we have a lot of these monitoring pages. So we've been taking all this data in, and so we've been playing around with various ways of kind of summarizing them and seeing at least getting some sort of look at the quality of the data. As David Lawrence pointed out in the meeting, we've been generating hundreds or thousands of histograms for all the data that we've been running over. So let's go through looking at a couple of those guys. So this is the main GlueX wiki page. There's all this information. You can see it's really easy to get to the RCDB, a lot of these other pages. So if we just go through one of these at a time. So here you have the plot browser. So the idea with this is that you can look at one plot over a large range of runs. So it's pretty straightforward. You can select the run period, the reconstruction version. So we keep track of all the different versions of data that we have based on the run period. So as time goes on, as the calibrations and reconstruction code get better, we'll write a new version and tag it like that. You can look at different run ranges. Also put in an RCDB query, and so when you go through, this is sort of the average occupancy of the main drift chamber for an event. So you can see right at the beginning, not too many hits. It gets a little higher as things go on. And then if you keep on going down.
When did the event
Yeah, that's what I'm trying to find. So, a little after this. You can see we had a lot of runs. Yeah. Okay, yeah, see, and so then eventually you go on and you say, hey, I have a little hole here. So, so this is really useful for seeing how things change as a function of time. I obviously, you probably want to look at a more restricted run range. Another thing is this run, the run browser? Yeah. So here you can go through. It has a list of all the main production runs, and there's a couple different ways that you can access information. So we have a few of the histograms set up here. So the way that you can look at them is you click on a run here, it will load the information over here, and so then you can just mouse over on all these different entries, and it'll show what the histogram is. We're only getting a little bit clipped, but it's a pretty good way of getting a brief summary of what went on, at least in this run version. You can see that we do all sorts of low-level histograms, some higher-level ones. You can look at how the particle identification is working, the time of flight. You can see here there's a little bit of misalignment in the detector.
This is version 1, right?
Yeah, this is version 1.
Okay,
so.
Good. That's
yeah.
So version 0 is direct from the counting house.
Yeah.
Version 1 is as soon as it hits the tape we run on. Mm-hmm. So the calibration costs, it might not be calibrated yet.
Yeah.
So this isn't so surprising. Hopefully version 5 it looks better.
Yeah.
Which is the one we just ran.
So yeah, you can do that. We also have some high-level histograms, so you can see. Okay, yeah. So usually if it was a later version, which I thought I had loaded, you'll see like an omega peak here, but not necessarily. So this kind of gives you a brief overview of what's going on. If you click this root thing button, then it pops up into another web page, and so here we have sort of a JavaScript root browser. So here you can go through and you can look at all the different histograms. Each of these directories corresponds to a different plugin that was run, and they have. So you have one for all the detectors that have different things. You can see that the Tiger microscope has a lot of different, has all sorts of different histograms. And then we also run higher level ones that have various calibrations, things like that. So this is kind of a good way to look at things and drill down if we see a problem or notice one right away, see how the data quality is. We also have this version browser that will look at one particular plot over different data versions. So here's the BCal beta versus p plot. I think it's beta versus p and u over p plots. And so you can see that at least a little bit as time goes on, the calibrations are a little bit better. So these guys are a little bit less spread out. Let's see, the last main one that you can look at, this is one of the ones that we're kind of working on adding more information to. So this is the time series page. It's a little slow to load, but once all the information is actually loaded, then you can kind of look around. So this kind of lets you look more easily at various time series of numbers. So here you have the different number of CDC hits per event. That's a function of time for various parts of the detector. You can look at other occupancy rates, and we're putting more calibrations like time resolution and things like that. I think there's a little work still to make it a little bit easier to use, but this is one of the things that we're improving for sure. And then if you're really interested in kind of the details of the jobs, you can go and you can look at we do some post-processing analysis of kind of the comparisons of the batch farm performance on these different monitoring jobs, things like that. I'm just going to point this out so that if you're interested in the gritty details, then you can take a look at this and then ask Paul about what he thinks about all those numbers.
Where was that link to this page?
It's still on the main wiki.
Yeah,
Launch analysis.
Yeah, this launch analysis. Yeah, that's the last one. So that's more of an an experts only page if you're interested in it.
Yeah, I mean, what percentage of the jobs fail?
Yeah.
How depressing that is.
So we'll talk a little bit more about that. Okay. So SciComp web pages. Mark talked a little bit about this before. This is kind of one of the main landing pages. So let me just walk you through a few of those pages as well. Once you submit jobs, this is where you can go and look for various information. If you're wondering, hey, why are my jobs not running? This is kind of the information that we have available to us to figure out what's going on. So, on the front page, they give some rough utilization numbers. If you do some mousing over, you can see that, what sort of extra information that they give you. So from here, you can see that what the batch farm utilization. It's running near. I guess it's 90% available, and then they have like another 7% that's free, something like that. No. So then you can click on this, and you get various information about the different job states. So when you're looking on here, the jobs go from pending, pending to staging, staged. They're running. That's when they're moving stuff onto the disk. Then you have the dreaded dependency job stage, which means that your job is sitting there in the queue and waiting for the tape, the information from tape to actually load. And then you can see various information about the different nodes. So this means, well, I guess one of the subtleties to just mention, not to go into too much detail about, is that we kind of have two clusters here, right? Because they support nodes for the experimental physics users, which are us, and then all the lattice QCD people. And they have the ability to move nodes between the lattice QCD farm and the experimental physics farm. So, if you see a node that says QCD, before it, that means that it's one of these lattice QCD nodes. And usually when it looks like this, they're moving them back and forth. So if you click on the batch farm, you can look at a lot of different information on this. You can do various searches. You can click on here. You get basically all the information that you want to see on the different jobs. So this is something that you can play around with if you need to use it. I won't go into too much detail about it. You can also look for information on the tape library, and this gives you a little bit more information as well. So that's another place to look at for information. So so that's kind of an overview of a lot of these web pages. So let's talk about some other basic things. So as Mark pointed out, we have this batch farm that has thousands and thousands of cores, and so we want to submit jobs, programs that will run over all these different things. And as you can imagine, if you're running over thousands of data files, it can be kind of tricky to manage all the all the different jobs that you've submitted. And so the JLab software that's used to manage all these things, it's called SWIFT, which stands for Scientific Workflow Indefatigable Factotum. So Chris Lariou came up with the name, I think. He's the main developer for this. So I had to learn that factotum. It basically means like handyman or something like that. So the idea is that you define all the jobs that you want to run over the data. You send them to Swift, and then Swift does all the hard work of optimally submitting the jobs and scheduling them and optimizing them so that they run in the most efficient way. Also gives you a nice interface for looking at the status of the jobs. If your job fails, you can retry it, things like that. And so, and and actually that's really one of the nicest parts about Swift. You know, Certainly if you're if you're an old-time JLab person, maybe you have your own workflow or something like that. You know all the ins and outs of Augur, but Swift makes it a lot easier to deal with any jobs that have failed, which is a problem if you have 10,000 jobs out there, or if maybe your jobs failed because you didn't give them enough memory, or you need to change some of the other limits and parameters. It makes it really, really easy. So I'll show a couple examples of that. So I'll go through a couple different Swift commands. If you type in Swift help, if you're logged into the queue, the online documentation is actually pretty good.
Can I make a comment? One thing Swift will do is it will try to optimize your access to the tape that we talked about.
Yeah.
If you're submitting one job at a time, the tape system doesn't know what's coming next, basically. But if you put them all together, then you can see the totality of your future requests and arrange your jobs such that stuff flows off the tape in the most efficient manner, or at least make some attempt to do that.
So yeah, so let me show you a couple different commands and what's like to work with Swift. So if I type in Swift list, I get a list of all the different workflows I have. Workflow is the basic set of data that you work with Swift. This is your collection of jobs. And so if you do list, it gives you kind of an overview of the different workflows. So here's a workflow that people are very interested in right now. This is our current set of calibration jobs. So you can see there's a lot of them. You can see that, hey, it's about 40%. So things are a little bit better. And so it gives you a lot of detail about the different states of the jobs. If they're, these are all the jobs that are waiting. These are the jobs that are sitting there waiting for data from tape. These are the numbers running, and it gives kind of a nice overview. Here are all the different errors. I won't go into the definition of what all the error codes mean, but the batch farm environment is always a very complicated system, so things are every once in a while things will go wrong. If you wanted to look at one particular workflow, you'll do that. You want to use the Swift status command, and this will let you drill down and get a lot of different information as well. So if you do Swift status -jobs, you wait a long time. This dumps information about all the different jobs, and so if you're it goes into way more detail than you usually want. But if you're trying to debug some things that are going on, trying to figure out what exactly went wrong, this is generally how you'll find out that information. Another way is that if you do useful one is if you do -problems, it'll tell you all the different jobs that failed and what the failure is. So that's pretty useful. You can also output things into different formats. If you want to dump into JSON or XML and feel like getting the data that way, do that. What are things do I want to show?
Resubmit your failed jobs.
Yeah, that's what I was going to do. So let's say that I want to redo these Swift system error, right? So if this error message meant that Swift made a mistake, there's something wrong that went inside of it, and so this just means that okay, we want to redo this one. Redo Swift, retry jobs, workflow, problems, Swift system error. and so when it does that, this is all database driven, so this is going through and modifying things inside the Swift job database. It's sometimes a little bit faster than others.
That's not a final timeout.
Yeah, that's what it's going to do. And so here it says resetting one problem job. So that'll get resubmitted. Another thing that we can do is modify the parameters of this job. So let's do this for the ones that timed out. This augur timeout means that you set a limit to how long the job is supposed to run, right? And so this means that the jobs I ran, well, they ran into the time limit, and so then augur looked at it and said, okay, we're going to kill it. So here we're saying, that we're modifying the jobs in this workflow for the ones that have this particular problem. We say time add, let's say 4 hours.
I think the time add needs to be for the problem.
Yeah, I think you're right. So this is a good example of one of the things is that, Swift is very powerful. It can be a little picky about the order of its inputs. Okay, that's good. And so here you can see that, here we had 88 jobs that timed out. We did this one command and resubmitted them. So, doing this is a lot easier than having to track down all the different job names and modify them and resubmit them all by hand.
Yeah, if you weren't using Swift before, this is why you should use Swift.
Yeah.
Because manually finding and resubmitting all 88 of those failed jobs is a huge pain. But there's command line, do it 2 seconds.
Okay.
Question.
Yeah.
If I created my workflow for a calibration version 3, for example, and I would like to submit the same workflow but with the newer version of the calibration, do I need to recreate the flow from the beginning?
Yeah.
Yeah, pretty much. I mean, it'll depend, a little bit on how you've structured your jobs. The scripts are running over it, but yeah, generally, yeah, that's the case. Okay, so let me just talk a little bit about how you add jobs in, just to explain a little bit about what goes into these sort of things. So, generally you won't be typing all this out by hand, right? You'll write a script to do it, and we'll have an example script that you can use to run over some of these jobs. But so the idea is that, when you add a job, you have to specify the workflow, you give the job some name. There's some information right here that's used by the batch farm for accounting purposes. So, generally, we say, for us, you're working with the GlueX experiment. If you're doing an analysis job, this is what you would put. You also put information for a simulation. There's some of the other things. All this different information is on the SciComp website. You want to say CentOS 6.5 to make sure that all your jobs properly run on the farm, because that's the operating system they use right now. Then you can specify the number of cores, the disk, the RAM. These are all the different various limits that you have to specify. Then you can also specify various input files that would get copied to the local node when the job runs. So there's a couple different things you can do. Basically, you can specify either a file that's on disk, or if you put in MSS dot the name of some file that's on this MSS subsystem that Mark was talking about. That's how you stage in a file from tape. So then you specify you want the standard error, standard out, put somewhere, and then you put whatever your program is that has some arguments. And that's how you generally organize that. So I showed some of these commands already. Retry and fill jobs. One other thing to remember about Swift is that when you create a workflow and you add a bunch of jobs, it doesn't automatically start submitting these jobs. So you have to explicitly say to run this workflow, and then it will start actually submitting the jobs. And so there are other commands like this where you can run and pause as well.
John,
Yeah?
can you go back? So the previous slide, pretty well.
Yeah, this one?
Oh, yeah. Yeah, so the standard out and the standard error.
Mm-hmm.
I mean, so I haven't been using Swift, I guess.
Yeah.
So I don't really know how to do it. Normally, if I submit a job, all the output goes to .farm out.
Yeah.
Tilde slash dot farm out, basically.
Yeah. Well, dot farm out in your home directory.
Right. So is that where those things, is that equivalent to that? Or if you don't, is that the default for those or what?
The default is still tilde slash dot farm out, but if you want them to go somewhere else, you can specify this.
Okay.
So for example, all the production runs, that we're doing, we have it write these to the write through cache, then they'll be backed up to tape.
Oh, and also you might want to put the yeah. Well, so you also might want to put them on the work disk or something like that, right? Because when you're submitting thousands of jobs, you have, right? You're likely to fill up your home directory.
So the default is the same.
Yeah, the default's the same. Okay. So
Swift is a wrapper around Augur, so it's just telling Augur what to do.
yeah, I made another slide last night and realized I forgot to put it up here. But so right at the moment, Swift is a separate system that interfaces with Augur. That's the batch management system, for the actual farm. But in the future, at least what they've been telling us, is that Swift will eventually bypass Augur, all itself, because it has more information about the global set of jobs. So, per person, Augur only schedules 500 jobs at once. So, if Swift works by itself, it can actually do a much more efficient job of scheduling. But when that will happen, I don't know. So now let's, at least for those people who have a JLab account, we can try and do an exercise and actually run over some data. So the way to start, what you want to do is to log into the iFarm machine. So that's these interactive nodes that we mentioned. And so to start off, what we did is that we installed all of the software that's on the virtual machine into this location and grouped all these software workshops. So for the most part, you're gonna load the software there if you source this file, either .csh or sh. Yeah. Mm-hmm.
Real quick, if you're not on the main network itself, in order to get to this iFarm, you have to first go through login.jlab.org. That'll be the first place you have to SSH to, and then you can SSH to one of these other farm machines.
Yeah, I forget, if you're on the Wi-Fi, do you have to go?
Yeah.
Okay. Yeah. That's fine. Yeah.
Probably flag Paul or I down and we can help you log in if you're having trouble.
Okay.
I get something like all my is not set.
Yeah, so you need to set all the my environment variable.
Where?
Anywhere personal area of yours.
Okay.
Wherever you want to work, just make a directory called all the my,
Okay.
and then do set in all the my in all caps.
Yeah, and so a good place to do that is on the work to the Haldy2 work area, right?
So work Haldy2.
Yeah. So if you do work Haldy2/home/ your username, I can do my Haldy my. Oh, so the minus p that that creates all of the directories in there, in that chain, right?
Makes it directly perfect.
So you can do this, set in hold my. That.
Can you
Yeah.
keep that path open for a sec?
Which one? This one? Sure.
Just give us all a chance to do that.
So, I mean, you just want us to put a local directory and then copy that stuff into it.
Yeah.
So it doesn't have to have names as relevant.
Right. Yeah. Yeah. So. Yeah. So this is just kind of an example. Using my area. Really, don't try and copy things into my location.
You don't have to type the entire first part here. The slash group all the way to the end is $workshop.
Yeah.
So you don't have to type that whole part.
Or you can load my slides and copy the file from there. But yeah. So all the files that you'll need for this are under this session 7b. The idea is that you'll just copy these into your local directory and we'll make some changes. So I'll give people a little more time.
I like how there's an old folder.
Oh, yeah, it's because there was, it was just old environmental files. So, Nathan changed the environment at the last minute, so I was just like, okay. I'll use his environment instead of the environment that I painstakingly set up.
What's the shortcut to that directory again?
$workshop.
Yeah.
The copy command $workshop gets you almost all the way there. Yep.
Okay, here, let me. Sorry. So here I can do. We do $workshop.
Just use $workshop.
Oh.
You have to source the environment.
Yeah, you have to source the environment. I know.
Follow your
How's that?
steps.
Or you had to run that.
Virus on the sidebar, which has
Yeah. Okay, here, maybe I have to make this even bigger. So here's another example that might maybe a little bit more readable. Okay.
Actually start your analysis will be helpful.
Anybody still running into any major problems? Okay. I can't help.
Set to be intense.
What?
Are you on the car?
I did the same exact thing.
You're there.
Yeah, but he didn't see the social and then see the session 7B.
Yeah, you already copied it. You already copied some. You even highlighted the line.
Yeah, I guess.
You already copied it.
Okay.
Team, she just recently set up an account, and when she tries to log into iPhone, it rejects her.
Okay, so why don't we
What's your username?
move on? If you still need help, people will help you. But so here's the idea behind the exercise. So, you want to go to the RCDB page, try and find some interesting runs, just like 2 or 3 or something like that. Look at the monitoring run browser page and, look at some plots, make sure that what's in there in the latest version is kind of reasonable. And so then we have this wrapper called, Swift GlueX analysis. And so the idea is that, that makes it really easy to, so this is kind of a wrapper around, it will create the workflow, add all the jobs that correspond to running over the REST files on data, in some run range. And so that will, just pick like, say two or 3 runs, something like that, and try this out. So while you're looking at things, let me So let me just point out a couple things in this script. So you don't necessarily want to run it just straight out. So you'll have to go through here and set a couple parameters. And let me just point those out to you. So these are all the different parameters for the jobs. So here you can see this accounting information and where you can find some links to where these are. Here are the resource limits. So, if you're just running an analysis plugin or something like that, then, something like this should be fine. All of the REST files right now are stored in this standard location. So, all you need to do is you need to modify these few lines. So if you put in the run period, current one is 2016-02. This is the latest data revision, and it'll automatically pick up the right runs based on that. So,
What file are you in again?
yeah. So this is a Swift GlueX analysis in the section 7B directory. Yeah.
I might have missed it earlier. In RCDB,
Mm-hmm.
what does it mean when the run number has a red box around it?
So that means that the DAC crashed at some point at the end of the run. So the run could be okay, it just meant that it didn't finish up cleanly. Okay. Okay, and so then what are the main things that you have to edit, right? So these things where it says change, so these are the other ones that you need to modify. And this is just the location, the various directories, right? So this directory right here, this one is where all of your output files will be automatically staged to. So generally you'll want to put that somewhere in the volatile directory. Here's the environment file that loads the versions of the GlueX software and sets up the environment for the job. So here you can just use the workshop one that we loaded. This is the script, that is the program that gets run. So here you should just put, whatever directory you copied files to, and put script.sh. This is something standard that you don't necessarily have to change. This needs to be a valid output directory. So this is where all the Janet configuration parameters get written to.
Somewhere you have write permissions.
Yeah, sorry, somewhere that you have write permissions. And so then what you do is you put in your plugins. And so the name of the plugins that you want to run. For us, this should be, for example, just Omega Ref. That's one of the standard plugins that we made earlier in the workshop.
That's the one I made during session 2.
Yeah.
The first thing I did.
Yeah. And then one of the things that was done that plugin is that the tree output was enabled, and so you want to put here the name of the tree. So if it was some standard name, tree output omega whatever .root, whatever the standard name that is generated by the analysis library. If you put that unique identifier here, then the trees will be automatically staged out. So we can do that.
So what do people need to change? People need to change this config file path.
Yeah, it should be the ones that are linked. So you want to change the output directory, location of the script directory, config file path. Both of these should be changed to your local directory.
So wherever we ended up copying that stuff to.
Yeah, wherever you ended up copying them to.
The environment file shouldn't change.
It can change, it doesn't need to.
We don't have our own copy of it.
Right. Yeah, for the purposes of this workshop. So in general, that's something that you would want to change, but not for this workshop. So actually, I have to change these as well. Go through and do that. Update that value.
What if you do the config file? Do you just use the one that's there?
For config.
Anywhere you want, as long as you write permissions.
Yeah.
Oh, so the config file path.
So that must change. That must change because you don't have write permissions on the file. It's going to make one.
Yeah.
So that config file is going to have all the arguments you're going to run Jana with. It's going to print them in there, and it'll run Jana by loading that file.
So here is an example. Hopefully I changed that properly. And I can try and run this.
Anybody need help?
So, okay, the one
It doesn't exist.
Let's see if that works.
So what it's going to do is it's going to create a config file anywhere you want. And when Jana runs, it's going to use this. So you can put this any spot you want, as long as you have
What
write
was the
permissions.
command you just did there, Sean, to make that second step pop up?
What this?
No. The one after you submit all these jobs, I saw you typed in something.
Yeah, that was Swift list.
Okay, so
Yeah.
it lists all the information.
File.
Yeah, for all the different
You want to use
workflows.
the one that's sourced.
Another directory.
Right. It's not really set up your environment. You want to have your source file. I think you want to keep that one.
So you'd like to use this home directory.
Anybody need help?
exactly. Or
Yeah, and this, so grab this directory. And we'll use that as the path. It's setting up configurations to the file.
It's gonna work.
So that will
There's always
Mission, so what I'm trying to do is I'm trying to create a configuration file that you can scroll through. Right? You don't know, right?
Yes, so what I'm trying to do is, they're gonna do this, so,
What is that file to change that?
yeah, because so there's the usage is that you need to name the workflow, and give it the upper and lower bounds on
This
whatever name you want.
I don't use a wraparound switch.
Buses, favorites,
It's going to create that file.
Okay, yeah.
I don't mind that sets all the money.
Yeah. This is what happens when we have last minute changes.
Alright, actually, I could just change the.
oh, yes, so you need to, yeah, you have installed UI, so you've made that.
Maybe can you do that?
Let's see.
Yeah, why don't we do that?
Yeah, so make this, so go to, any place you'd like to do. So if you're in your home area, you can just, or yeah.
So I just put that on there.
Yeah. And then set in this path.
Oh, yeah. So,
So we need to set this variable. So you created a directory, on UI, and then we need to set this variable to the path that you just created. Yeah, so if you set in.
have you been a SciComp certificate again? What's the command?
Go to the website.
No, there's just
I don't have
So
that.
he has an example here of what he submitted is 1096, 10906 to 10908.
Okay.
So that's one choice of runs.
Site bin JSON dash create. To be honest, it could be anything. That's the name of the
So now your environment should be
dash
good.
create.
There are no errors. Yeah, so
So you can do Swift list.
didn't I?
Yes.
once a year. Maybe it's once a couple years. I've had to redo it.
Once in a lifetime.
So there's two SciComp keys.
Certificate.
Certificates. Okay.
Yeah, so you do JSert dash create.
There's multiple people with this problem.
Can we write this on, so,
Yeah.
if you're having issues with the certificates,
Hey everybody.
If there is no window, yeah, then it should automatically do.
search what? Dash create. Okay, so if you get some error that says you need SciComp certificates, type jsert dash create, and that will create your certificates, so you should hopefully fix those errors. Well, so did you, when you came into the admin, when you did the login, from the beginning, to get the external here. Yeah, sorry.
Yeah, there's a fellow column.
Like half an hour.
Sorry.
Oh, wow. So you have jobs on the farm now. So if you go to maybe
Okay.
you can find that link to the website.
And you don't have Ron, you're next.
Just Google JLab site.
Oh, the line above is commented.
Yeah, here. Okay. So here is the page you're looking at. And so if you go to jobs, you can see your jobs. Oh, no, missing one more step. So the last step is to actually start the workflow. You need Swift workflow name and then run.
Swift start.
Run. Or maybe you need
Big file path.
I mean, Swift dash help.
Oh, you need a name.
That's also a name. Yeah, before.
Like a file name.
I can't put a fence.
Give it a name.
Swift minus.
Do I need to like a
What I did. I don't, you don't. That way you can see.
And maybe you need run before. Yeah. So Swift and then yeah.
Right.
Oh.
Okay. So now it may take a minute, but they should appear on this web page as okay, so you have Emacs, so you're starting. Let me see if I can get out this job.
So I actually did see.
Okay.
Fortunately, at the beginning and end running
Okay.
I started there were no jobs. So now what I need, maybe I gotta delete that, or I guess I can just.
Let's see what the status is. So you can do status dash workflow.
Right.
Okay, so there's 17 jobs dispatched in your entity. So if you go to the site web page, you can see those live there.
I gotta go back and help somebody else, but when that loads, just pick like 11,000, 10,873.
So when you see if you go back to your terminal, you see these things, that means it's putting jobs into the workflow.
That's what I thought it did.
Well, so if you type this Swift pi execute this guy with the same workflow name and a new set of run numbers, it will try to create this workflow again. But if it already exists, then it will just add these new jobs to the same workflow.
Okay, see, I thought it failed.
Okay, yeah, so this is an error because it failed to create it, but it's still spitting out all those things and it is actually. Yes, I think
Despite myself.
You won. Yes, yes. Well, let's see, so this. Yeah, so you should be ready to try it. And now you can go here and do this, execute this. Python dot slash.
What's in your postdocs and
Yep, just like an executable. And so do dash help first. Or let's see, well, you can just execute without any options. It'll tell you the.
Anybody need help?
No, just without any options. Yeah, just try to execute it. So it'll tell you that the usage
So that's the
is
thing Justin was talking about. JSON
and then a beginning and end run number. So what runs do you want to actually the workflow is a unique name that you want to provide. So you would say Frank's workflow. It will, when you access this workflow and you want to check its status, you need this unique identifier to check how your jobs are doing in the actual So you can say workshop anything you want. So that you can remember it. And then you need
Start with this one.
Anybody else need help? Help?
Okay, yeah, so they're in pending state, which means they're waiting for the first job.
Not quite yet.
Get into our accounts and write a check.
And there was also some parts before.
It has to be made out, but it's made out.
Okay.
Wouldn't that be
By the way, so I don't get that one. It's just what is Skype?
You can write this down here, I think.
So I had to take it by hand. So
Yeah.
I like that one very much.
Yeah,
Also
right.
the output.
Yeah, it's pretty good, right? Oh, yes. So you need this command over here. So at the moment, you don't have a certificate to actually submit jobs. But if you type this command, jsert, and then create a single command before execute. This is a one-time only thing. So this creates your certificate for forever. You can submit jobs. Yes. Yeah. So it creates a certificate for you to have access to it. Without that, you can't submit jobs. So one way to put in the run number that you press, so one of the runs was 109. And so here, I'm sorry.
That's all.
I thought something about I could just get my JLab account and I wanted to do tool analysis on my trace tree or something like that. So to get the feeling, there are a lot of information where you can check things, take a look how data looks like. But what are the necessary steps, let's say, which I have to do if I want to do that? Omega 2550, something like that.
That would be start with this step. Run the form jobs and
I assume it would be in my.
basically, from here, you're starting the process at the beginning of the workshop. So the first thing that Paul did was create this Omega Ref plugin.
First thing you need to do is a plugin to is basically analysis.
Oh, no.
Yes, the thing that creates jobs
You
you
don't have to.
So Paul created that plugin And there's a solution, the plugin that you're running now with data.
Sorry.
The one that was created.
That's my context.
Okay, probably, but I have to check out the software beforehand and install it on my home directory or something.
Well, so you're currently using the version of the software that we set aside just for this.
Sure.
So if you want to just use that, you can do that.
I just want to
do it what's already there.
What is recommended? Of course, one could use now this virtual machine basically probably to do real analysis, I'm not sure. Or
No. The virtual machine is so working on the iPhone like we're doing now is exactly what you want to do. And we have the build of the software we use in the workshop is available there.
But you haven't
source this environment script.
So that's the Swift
applying
run.
that software. So you're using all the libraries that we use on the
Okay, I see. That's pre-compiled.
the code exists, and so all you need to do is build a plugin.
So that created,
I see. So that would be the step to source the environment, set up the software, create the plugin, and do I have to compile that first that it is accepted or something?
It's already compiled for you in this current version, but you could make a new directory where you created a new plugin from scratch, like Paul did. You use this big plugin command to create a new set of files, and then you could compile that and have a new plugin to.
So this make plugin
Let me see if I can fix
script
that.
is available once I source these environment
Yes,
things
so once
from
you're on the iPhone, it will source, and then you'll have that in your path. So you just type in a plugin and it's created.
I see, and then I do the modifications I want for my analysis.
when you
so
say
the
batch
same
system.
And then basically from there, you have the root tree,
And as
which
I
means
know,
you've done all the processing steps after that to use a deselector for
Right.
your events and root, and then
Right.
create an amples file from that, and then run my
I think underneath, I
What
think
happens
if
if
I
I'm running
Okay,
I don't know, 5,000 jobs to run all of the data, then I get probably 5,000.
They call it Augur here.
And then I have to somehow
They have their
manage
own-
to these
they have their own job
5,000 also
spaces.
files.
They call Augur.
Right, so then
I think underneath it might
in
be
the
now.
deselector, for example, this
Okay,
run
when you
deselector, there's a key chain inside of there, so you can add all the files that you just
But
created.
that's a record through those things.
That will process all of those for you inside that deselector.
To, let's say, create the T tree which you want to operate and do the last part of the
Right,
analysis.
so then that would create
Whatever the
output
email that
trees,
Paul sent
which has
is the case,
just
so probably
events
just
that pass all of your touches. And then that you would run this tree to Antlers and which would output this file that just has the 4 vectors inside.
Is fast enough to do the analysis on the full chain, or is it reasonable to also split that into jobs again? Because I mean, if there are 5,000 outputs or so.
Depends on how much data is in these 5,000 jobs you're looking at. If you're going to look at the full analysis or the full data set from the string, you probably need that to be in some kind of a farm job.
So this is what you would probably do.
Yeah. So we're using these farm processes, the same Swift commands you can set up instead of running over these REST files, which are reconstructed data. You can set up a separate Swift workflow, which just consists the root trees. And so you can have that access to root trees that are in your private folder somewhere. So instead of running a plugin with the HE root inside of our full simulation reconstruction, you'll run root minus b minus q, run deselect these set of runs. And that would run inside your farm job and process those and have some other output, which is a small set of files that we'll use. So we didn't go quite into that detail here, but with the tools, this Swift Python script, you can modify that to give you another set of files, which then run over a separate selection of data. Swift is actually smart enough to do things in stages. And so you can actually do stages of processing where you run the REST files first, produce a root files, and then tell Swift you want to run the second iteration and have a separate step which has a run deselect, which will take the files from the first piece and then run the second one.
So then you do space.
The next step of the
So this kind of condensed information, so to say, how do I really do from the first step on the analysis? That would be very helpful. I mean, I don't want to be lazy, of course, and I probably could somehow find all these pieces together and put that together.
It's some cobbling together of everything we discussed.
Yeah, I mean, there are a lot of different aspects which you have to keep in mind where things do what, so to say. In particular, this submitting out to many jobs and so on. How does it handle when I have, I don't know, 100 runs or so? How does it separate this data into
exactly.
jobs? Does it then make 100 jobs out of that, or is this flexible?
If you look at what's scripted in your
So try doing the status.
terminal
Someone
here,
did 10 jobs, right?
yeah, it's
From
submitted.
3 runs.
Okay. Yeah, so the one thing is that there's a little bit of a lag.
Yes, you had 3 runs, and it should have, or only 2, it looks like
Okay, Ron, you should be in business now.
Maybe this was a bad run. So at the moment in this, so what it does is this Swift Python script is looking in the directory where we have these rest files and saying for each one of those files, create a job which analyzes all the events.
Run
inside
is
that file.
multiple jobs, so to say. Run is multiple files.
One job per file.
Okay, this is
So for these runs, at the moment, we've only processed 5 files. And so there's 5 jobs for each of these runs. And so it will then take those, it will make a root tree and a histogram file for each of those raw data files.
All right,
And put that
so,
in another directory. That you'll access later. And that's happened.
We're going to go ahead and end the session now. There are refreshments outside. Of course, if you still want to keep working on this, we'll be around to help. This was the end of us showing you, how to do an analysis from hopefully, start to finish. We will have later sessions where we can individually help you. Like if you had troubles with the exercises because we went too fast. That would be a good time where we can help you. Or if you have further questions, we will have sessions later in the day to help you out. But for now, this concludes the main portion of the workshop. I'd like to thank everybody who helped make this happen. So, of course, thank our guest speakers. Nathan, who made the virtual machine and set up all the software and made sure it worked. Sean, Justin, and Mike, who made sure that, they got all this Swift stuff working, did the analysis, generated the data and did everything. So thank you all for coming. I hope this was helpful. And again, we'll be here to help for the rest of the day. And there's coffee and stuff outside. But thank you all for coming.